Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is 7 ways to find things in the sky. And to help us learn about that is our guest, Ed Anderson, from the Custer Observatory and the Astronomical Society of Long Island. Ed, welcome to the show.
Thank you. It's a pleasure to be here.
Now, can you take a moment or two and tell our viewers a little bit about yourself?
Certainly. I am an amateur astronomer on Long Island. I've been doing this for about 8 years. I'm a member, as you said, of the Custer Observatory and the Astronomical Society of Long Island. And I meet with a lot of new people as well as our club and the observatory to share information to the public.
Well, that's good. So I tell you what, let's get into our topic. So my first question is, why do people buy a telescope and then drop out of the hobby within a few months?
It's a good question, and one that I've discovered to be a real issue as I have learned to work with new people. Once they've observed the moon, maybe a couple of stars, a few things that they can see visually, they become frustrated because they don't know how to find things in the sky. And so I've put together this talk about how to find things in the sky to help them progress.
So what are the 7 ways to find things in the sky?
Well, let's start off with visual, based on what we can see. You look up in the sky, you can see certain things. You can look with your eyes, you can look at it with binoculars, you can look at it with a telescope. Depending on how much light pollution you have, you may see a great deal up there or not much at all. I live in a very light polluted area. There's not a lot in my sky. A second method that is still visual is called star hopping. If we look at a star chart and use a degree circle, which is a little aid device that we have. You make a circle out of wire and you put it on the chart. It kind of shows you the field of view of your telescope, and it can help you plot out a path from something you can see to a location that you can't see. Think of the old Hackstrom maps. Sure. Turn right here, turn left, turn right, and there it is. Only in this case, you can't see it until you get into the spot because you need your telescope to see it.
All right, so we talked about the star hopping tools right there. We have the image up on the screen.
Yeah, so you've got a variety of targeting tools. Down in the center is a red dot finder. Down below that is a telrad, which projects circles up onto the screen. What's represented in the eyepiece is you want an eyepiece that has a wide field of view to let you see as much of the sky as possible. And again, that eyepiece will help you see things you cannot see visually.
Exactly. We'll magnify things, magnify the light gathered by the telescope. So for the visual, for the binoculars, any particular size would be good for someone to start with?
I usually recommend that people work with binoculars that are 10 power or less. More than 10 power, we all tend to jiggle our hands a little bit and it shakes the image. I use 10 by 50s, 8 by 40s. I have 7 by 35s. I use them all. So those would be the sizes that I would recommend.
Also, fact, they're easier to hold steady unless you were to go with a tripod mount.
That's right, a tripod mount or even a monopod mount. These are things you can use camera mounts. They don't have to be specifically to astronomy.
Exactly. I've even seen some folks that use binoculars use the parallelogram mounted onto a substantial tripod.
That is the best way to use binoculars, but also the most expensive. You know, those things cost $300 to $400 just for the mount. I'm recommending to somebody to buy a pair of binoculars. Even $25 binoculars will show you more in the sky than you can see with just your eyes.
So we've got the visual techniques. We talked about star hopping. What's next?
The next one that people normally are introduced to or think about are the computer-assisted methods. These would be push to, which is kind of a hot and cold situation. You put in that I want to see the Orion Nebula, for example, and it'll guide you and say, push the scope a little bit to the right, lift it up a little bit over here, you should be looking at it. Then you have what's referred to as the go-to, which are fully computerized, fully motorized. Consider these robotic. This would be similar to what they use in an observatory. These are both based on encoders. These are magnetic devices that are in the mount itself that basically judges where the scope is pointing by so many clicks, so many movements. There's a third method that has become growing in popularity called plate solving. This is based on a camera that actually images the sky, compares it to a chart, and says, okay, I know where I am on the chart. Now what would you like to go see? And then it will help guide you to the location using those same encoders. Okay. So that is one use of plate solving. The other one, and I know that we have some slides there. If you go to the computerized mount based on plate solving, this is one where we use a smartphone in one of the most popular telescopes we have out today for beginners, and the one I mostly recommend. This actually puts your smartphone on the mount, and the smartphone images the sky, compares it to the chart, puts a graphic up and says, okay, I know where I am. Point on the chart. What do you want to see? And I'll show you how to get there. It's a fantastic device. The telescope shown on the left here is about $350 to $450.
Okay, yeah, with the new planetarium software programs available for smartphones, you can make use of both technologies.
Yep. The scope shown here is the Celestron StarSense Explorer line. And if you've got people who are looking at this and saying, gee, what telescope should I take a look at? This would be one I would recommend.
I took a look at it myself the other day. So it's very interesting indeed. Now, a little earlier, we were talking about push to. And there's the traditional push to, which is just the reflecting telescope on a Dobsonian mount. And then there are the Dobsonian mounts that have encoders.
Yes. Yeah, the term push to can mean either, but because all telescopes, manual scopes, you're pushing them someplace. You're the driver. But when we refer to assisting to help you find things in the sky, we're talking about the encoder-based mounts.
All right, and here we have the plate solving go-to right here up on our screen, and folks can see how their cell phone attaches to a mount adjacent to the scope.
Yeah,
and
the scope on the right is actually a very advanced imaging system that where I said the one on the left's about $400, the one on the right's about $4,000.
Oh my!
And that actually will take pictures and do timed imaging. It's a very advanced system, a little out of most beginners' price range right now.
Yeah, I would say. Now the one on the left there from Celestron, I noticed that that's still a manual. That is not computerized. So you would have to follow the instructions on the screen of your cell phone and use the manual controls for up, down, left, right to actually get the object in your field of view.
That's correct. It's computerized in the sense that your phone is the computer.
Exactly.
And is doing the imaging and is giving you directions, but you physically move the scope. It also has slow motion controls on it to make it much easier to do that. But yeah, this is the family of scopes that I'm recommending to most people right now.
Yeah, and like I say, the one on the left, price range is affordable compared to what you could spend in this hobby, which would be kind of like a money pit in a way.
Yeah, there is a model in this series that's $180. The one that's shown here is around 400.
Okay.
It's a little bigger.
All right. Well, so this is a good look at some of the ways to find things in the sky. We're going to take a quick break right here. If you have a question, please send us an email. You can see the address down at the bottom of your screen. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is Fast Radio Burst. We're going to be calling it FRB for this talk. The first FRB was described in 2007 by Duncan Lorimer and his student David Narkovic from archival pulsar data recorded in 2001 at the Parkes Observatory. They last between a fraction of a millisecond to a few milliseconds, or thousandths of a second. They are not related to incidents where a microwave door caused radio interference. Over 500 FRBs have been detected. Some FRBs periodically repeat. One example repeats every 16.35 days. Most bursts originate outside of the Milky Way. In 2018, the CHIME radio telescope became operational and detected the first Milky Way FRB in 2020. This event was associated with a magnetar. While one FRB is associated with a magnetar, it has been suggested that there may be more causes. Numerous causes have been suggested. Since bursts are from all directions, they must be from outside of the Milky Way, or at least most of them. These must be very powerful events. The shortness of the signal suggests that the origin object must be very small, less than 1,000 kilometers or 600 miles across. A larger source would need a synchronization mechanism. And that is Term of the Month, Fast Radio Burst. Back to you, Don.
Thanks, Stephen, and welcome back. We're here with our guest from the Custer Observatory and the Astronomical Society of Long Island, Ed Anderson. Now, Ed, I understand that you have an interesting story about the plate-solving telescope we talked about in segment 1.
Yes, I have a friend who has one of these. He's an astronomy hobbyist. And he brought one of these Celestron StarSense Explorer scopes to a Sweet 16 party. And the party was an outdoor party. It ran into the evening. And he set this up. Now, we're talking about teenagers who have no knowledge of astronomy, have never used anything like a telescope. He set this up. He put his phone in it. As soon as the phone went in, the kids were immediately interested. It took him about 5 minutes to get the system set, and then he turned it over to the kids, and for the next 3 hours, they were discovering things in the sky simply by pointing at them on the screen, and the scope would tell them where to, the phone would tell them where to point the scope. So that's how easy this is to use. For anyone who has used some of the go-to scopes or some of the older push-to systems that are based on encoders, getting them aligned, figuring out how to use them can be fairly complex. This thing is stupid easy.
Wow. Interesting story, and it's great to get the younger generation interested and involved in the hobby and science of astronomy. Now, I want to ask you next about setting circles. How are they used?
So setting circles is a method that I like to talk to people about. We're talking about here about altitude and azimuth tools. And why I like to go into this so much is because you can take any telescope of any type and use this method with it without having to buy computers, without having to use smartphones or anything else like that. And what we do is we get something like this. You should have stuff on the slide, but this is an angle gauge that you would use on a table saw.
Right.
It's used to measure the angle of the saw. Well, we take this and we put this on the barrel, on the tube of the telescope, and it will tell us how high the scope is pointing into the sky. That's the altitude. You put a graduated circle on the bottom of the scope. If you take it down to the next, I think you have a next image, which shows mounts with circles on them.
Yep.
These are azimuth circles, and this is like a compass, 360 degrees around the circle. And so if you use an app on your smartphone, like Stellarium or some other astronomy app, you can go in there and get the altitude and azimuth position of any object in real time. So you rotate your scope, find that number on the azimuth circle, tip the scope up, read the angle on the angle finder, and it will point you where the object is. Using that wide view eyepiece that we looked at earlier, you should have a very large area, and 95% of the time it'll be within that field of view. I like this because, oh, gee, I bought a scope. It isn't computerized. I bought the wrong thing. Nope, no problem. These things cost between $15 and $30. On that image you see in the lower right, I printed out a paper circle using an app on the internet. I have scopes of all the types that we discussed here so far for finding things. This is the method I use most of the time.
Now for alt-az, though, that's based upon the location of the particular individual. So for me here in southeast Michigan, it would be different for you on Long Island.
It would be slightly different, yes, and your phone app that you're using to get your real-time positioning should adjust for that.
Ah, good to know. Good to know.
Okay, because if you go in, again, Stellarium, wherever, one of the first things you tell it is where you're located, or the phone tells it where you're located.
All right, so we've got the setting circles covered. Now, what's the difference between an alt-az system and an RA index system?
So an RA index system is based upon the equatorial coordinate system. If we think of it this way, if I stand and I look out at the horizon, I'm looking at a circle around me and altitude above me. But that's not how the Earth works, and that's not how the universe works. What we see going by us in the sky is based upon the tilt of the Earth. And so if we took that alt-az circle set and we tipped it so that it matched the rotation of the Earth, we would have a new coordinate system, which in astronomy is referred to as right ascension declination. Going into where those terms come from is more than we have time for, but let's just say that that's the astronomical coordination system based upon the position of the Earth, rather than altitude azimuth, which is based upon my position on the Earth.
Exactly.
All astronomy charts, all astronomers, observers work in the right ascension declination system. I try to shy away from it with new people because they're not familiar with it. Altitude, azimuth, it's just like using a camera tripod. Everybody understands how to do it. Right ascension declination is really the right way to do astronomy, but you got to be into astronomy and study this to know how to use it.
Yeah, basically it's the longitude and latitude for the sky.
Exactly. Mm-hmm. And to use it properly, you need an equatorial mount for your telescope. And again, talking about beginners, the beginner equatorial mounts are not very good. They have a lot of play in them, and I recommend people stay away from them. If you get heavily involved, you want to get committed, you want to really do this right, then you get an equatorial mount. But now you're talking $500, $600, $700, $1,000 just for the mount.
Right. Easily.
Easily.
Yeah, easily indeed. But so these types of systems that we're talking about, the equatorial, this is what's used in an observatory as well, correct?
Yes. And in fact, if you have an image says RA/DEC and the equatorial mount, there's an image on that one, and you see that the scope starts off at a tilt. And that tilt aligns with the tilt of the Earth. So again, to you and I, as people who are involved in astronomy, this is obvious. To the first person who's bought that first telescope, this makes no sense at all.
Right. Yeah, they've got to learn the jargon, the coordinate system. But if anybody is really into it, they'll spend the time, like you and I did, and learn how this works and understand, like you say, the Earth's tilt and how that affects what we see, the plane of the ecliptic, and why Orion is so high in the winter and Scorpius is so low in the summer. It all ties in together.
So that is really, we've come to the essence here of why I've highlighted 7 ways to find things in the sky. Because for some people, working with a computerized scope is challenging. They don't like computers. They don't understand how to do them right. And if you don't do the steps in order, you're going to fail. And so their friends will tell them, get a manual scope, learn right ascension declination, do all of this. Maybe that works for them. Me, I happen to like this Alt-Az method. Even though I have a go-to scope, even though I have a push-to scope, this is the one that I like most. So with having 7 options, you've got plenty of ways to learn how to find things in the sky.
You sure do. And of course, people ask me, and I'm sure they've asked you, what's the best scope to get? The one you're going to use.
Oh, yeah. Actually, when I'm advising people on buying first scopes, I spend more time asking them where you're going to store it, where you're going to use it, and how are you going to move it before we ever talk about buying anything.
Exactly.
Because these are other points of failure that we don't have time to go into here, but you get a friend who says, buy the biggest scope you can, you get it, and then you can't move it around, and so it ends up as a lump in the garage.
Now, when anybody does buy a telescope, people always have certain expectations. And in the last 2-3 minutes we have here today, let's get a little bit into expectations.
Well, I think I told you about what I expected when I got my ETX80 go-to scope. And you have an image for this. So, I mean, I had seen pictures of the Andromeda Galaxy in books, and I said, oh, wonderful, my little 80 millimeter telescope is going to let me see this.
Yeah, that's
And
a Hubble
so
shot, right?
I set it all up in the side yard in my very light polluted area. And if you go down to your next image, what I saw in my ETX80, I said, where is the Andromeda Galaxy? Right. And the little face on the side was my face. And I was so upset and angry that this computerized scope that I had spent $350 on wasn't showing me anything like what was in the magazines. And so I went and got a bigger scope. And if you what I saw from my home in an 8-inch Dobsonian scope was this little bitty blob in the sky that I could barely see and could easily have overlooked. And I was still frustrated. Well, finally, I took that scope out to a dark location called Cherry Springs. And with that bigger scope, that 8-inch Dobsonian scope, and very dark skies, what I saw looked something like the image that you have on that slide. Still nowhere what I expected from my little bitty scope. But now I had learned what to expect, and very smart people had advised me. So I bring this up also when I'm working with new people. What do you think it's going to look like in your $39 Kmart telescope that you just bought?
Exactly. It isn't going to look like the telescope that belongs to all of us, which is the Hubble.
Right.
Ed, I want to thank you so much for joining us today to help our viewers find things in the nighttime sky. We'd invite our viewers to visit our club website, the address of which, as always, is down at the bottom of your screen. And coming up next to finish off the show is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for July 2022? We just had the solstice, June 21st, so that was the longest day of the year. Days are going to be getting shorter in the northern hemisphere, longer in the southern hemisphere. Next we move to the moons. On the 6th, we have our first quarter, full moon on the 13th, third quarter on the 20th, and new moon on the 28th. At the very end of the month, on the 31st, we see Mercury in Leo. So Mercury goes from Taurus to Leo over the month and has superior conjunction, which means it goes behind the Sun on July 16th. Now Mercury moves pretty fast, so you actually get to see it in the morning on the 1st and here in the evening, just before sunset, on the 31st. So I'd like to look at Mercury when it's in the evening because you can wait for the sun to actually set and then you can go search for Mercury with your binoculars. Back to July 1st, in the morning, we have the whole planet lineup. Mercury, Uranus, Mars, Jupiter, Neptune, Saturn, and really just off the edge of the screen is Pluto. Mercury is in Taurus, Uranus is in Aries, Mars is in Pisces, Jupiter goes from Cetus to Pisces, Neptune is in Pisces, and Saturn is in Capricornus. And that leaves Pluto, where I'm showing it on the next slide. On the 19th of July, it's at opposition, and it's shown here at midnight. So we're looking more or less south, and just to the left of the teapot in Sagittarius, you'll need an excellent sky chart, but Pluto is probably about the easiest to spot at opposition when it's pretty dark out, like at midnight. So you'll need a decent sky chart. You might bring some warmer clothes with you. You think, oh, it's been hot, but you know, it still gets cold by midnight sometimes. So that's what's up in the night sky for July 2022. Remember, we don't charge for this show, but we may tax your brain.